Turn to page 181 in your books to number 70. A television camera at ground level is filming the liftoff of the space shuttle at a point 800 meters from the launch pad. Let theta be the angle of elevation of the shuttle, and let s be the distance between the camera and the shuttle. Write theta as a function of s for the period of time when the shuttle is moving vertically. Differentiate the result to find d theta dt in terms of s and ds dt. So first we have to draw out the figure. The camera is at ground level 800 meters from the launch pad. Theta is the angle of elevation of the shuttle, and s is the distance between the camera and the shuttle. The first part of the problem wants us to find theta as a function of s, which means we're going to use this s in our equation. But since it's a right triangle, we're going to have to use SOHCAHTOA. So since we have 800 and the s, that is adjacent to the theta and the hypotenuse. So we're going to use cosine. Cosine of theta equals adjacent, which is 800, over hypotenuse, which is s. But it wants us to find theta, so we're going to have to use the inverse trig. So theta equals arc cosine of 800 over s. So that answers the first part of the problem. Now we have to differentiate this equation. Since it is inverse, we're going to use this equation. So the derivative of theta is d theta dt equals negative u prime. So the derivative of 800 over s. The shortcut for a fraction with a variable in the denominator is change the sign. The top stays the same. Add 1 to the exponent. All over the square root of 1 minus u squared. So 800 over s squared. But you have to kick out the implicit, which is ds dt, because there are two variables, theta and s. So now we just simplify. D theta dt equals, two negatives make a positive, so 800 over s squared equals the square root of 1 minus 800 over s squared times ds dt, and this is your final answer because it wanted it in terms of s and ds dt.